So picking up where we left off, which is on this problem here, we are still trying to, the directions back here, we're still trying to use the limit of Riemann sums to evaluate this area. So now we're on the interval 0 to 5. I'm going to graph this. So if I plug in 0, I get 25. If I plug in 5, I get 0. It's something like this. Okay, so delta x will be 5 minus 0 over n. So delta x is 5 over n. F of xi. So the original function is 25 minus x squared. And in place of our x, we put a plus delta xi. So a is 0. Delta x is 5 over n times I. So this is 25 minus 0 doesn't need to be there. So when I square this, I get 25i squared over n squared. So that is my expression for f of x sub I. And third step is to set up the integral. So we want the integral from 0 to 5 of 25 minus x squared dx. And that's equal to the limit as n approaches infinity of the sum from I equals 1 to n of delta x times f of x sub I. So delta x was 5 over n, and we're multiplying that by 25 minus 25i squared over n squared. And before I get into the summation, again, you don't have to do this. I just like to make sure that I'm not missing anything. So before I get rid of my summation, before I get rid of the sigma, I am going to add all this together. Or I like to distribute before I add all this together. So 5 times 25 is 125 over n minus 125 over n to the third times I squared. Now I can take the sum. All right. And so the sum of this is 125 over n is a constant. So it gets multiplied by n. The sum of this constant times I squared is minus 125 over n cubed. And then, what is the sum of I squared from 1 to infinity? That's the n times n plus 1 times 2n plus 1 all over 6. Next step is to take this limit at infinity. Remember, this is really just asking, what's the horizontal asymptote? So for the first term, the n's cancel out, and you have 125. For the next term, you have 125, negative 125 times 2. Let me write this down. Negative 125 times 2 divided by 6. So I don't want to double this and then reduce, so I'm going to reduce first. So it's minus 125 over 3. And just to continue with our decimal approximations, so that's 125 minus 125 over 3. If you were keeping in full fractions, you would just do, so that's 2/3 times 125. You could do it that way. So it's 83.3 repeating. And I'm not putting an approximation symbol on that because this is the actual area between 0 and 5, between this curve and the x-axis. So that is the final answer. Same idea for the next one. Okay, do you have to graph it every time? I guess not for the Riemann sums. It's kind of nice to have that picture in your head, but if we're doing an abstract Riemann sum, I don't need to look at left versus right. So let's just go ahead and do it without the graph just to see what that's like. So you still do everything in the same order. Delta x is 5 minus 3 over n, so that's 2 over n. F of x sub I like to set up the function first. So the function is 1/2 times x squared minus 2. What goes in here? It's a plus delta x times I, which just means, remember, this means you're starting the first rectangle somewhere. So it could start at 3, which is a, or I could add any number of little delta x's to that and say my first rectangle starts there and everyone spans from there. So that's 3 plus 2 over n times I. And then let's do the algebra out here so that we don't have to do it all with the summation notation. So 3 squared is 9. 3 times 2i is 6i over n, and then you double that when you're squaring a binomial. So 12i over n plus 4i squared over n squared minus 2. 9 over 2 minus 4 over 2 will be 5 over 2 plus 6i over n plus 2i squared over n squared. So I wanted to get this math out of the way. 9 over 2 minus 4 over 2. Okay, so that's my f of x sub I. So step 1, step 2. Step 3 is to go ahead and set up the integral. So we're taking the integral from 3 to 5 of 1/2 x squared minus 2 dx. That's exactly equal to the limit as n approaches infinity of the sum from I equals 1 to n of delta x times f of x sub I. Reminder, why is it that again? Remember, we're adding up the area of all these rectangles, and they all have a base of delta x and a height of some x sub I. So that's why we do that. Delta x was 2 over n. We're going to multiply that by 5 over 2 plus 6i over n plus 2i squared over n squared. All right. What if we I'm going to be brave and just go ahead and do my summation here. So 2 over n times 5 over 2 is 5 over n. That constant gets multiplied by n because I'm taking the sum. Okay, what am I going to have out in front? 12 over n squared, if I distribute through, times what's the sum of I? N times n plus 1 over 2, plus 4 over n to the third. And what's the sum of I squared? N times n plus 1 times 2n plus 1 all over 6. So what is this limit? So this is just 5. Then we have 12n squared over 2n squared, so plus 6. Then I have 8n to the third over 6n to the third, so plus 8 over 6, which is really 4/3. So 11, so 33 thirds plus 4/3, 37 thirds. That's the actual area between 3 and 5 of this f of x dx. Oh, and that was the last problem. Now, are we going to have to do these by hand all the time on the free response test? No, but there are often maybe 1 or 2 multiple choice problems where they'll show you like the setup, the f of x sub I, maybe without simplifying it, times the delta x. And so you might have to try to figure out what the function was, or pick out the correct value. So it can be kind of tricky. I'm trying to find these problems in AP Classroom to give you more examples. But this is the basis for how we're going to get to our shortcuts for definite integrals.